Hi everyone, I'm Dr. G. Srinivasu, Associate Professor, Department of Mathematics, Institute of Aeronautical Engineering, Dundigal, Hyderabad. In the present video, I'd like to discuss some practice problem on Lagrange's linear equation. Already in the previous video also, we have done some problems on Lagrange's linear equation. And in this video also, we want to solve more problems on Lagrange's linear equation. So before going to the problems, I want to tell you what is the Lagrange's equation. So we know that the Lagrange's equation is an equation is of the form PP plus QQ is equal to R. The Lagrange's linear equation standard form is, if it is in the form P into P plus Q into Q is equal to R, where P, Q, R are the functions of X, Y, Z, where P, Q, R are the functions of X, Y, Z, then this equation is said to be Lagrange's linear equation. And this equation can be solved by considering the subsidiary equations, and on solving, we can write the solution. What are the subsidiary equations? The equations are in the form dx by p is equal to dy by q is equal to dz by r. This is called the subsidiary equation, and this equation can be solved by using method of grouping or method of multipliers. And this equation can be solved by using method of grouping or method of multipliers. And finally, the solution will be in the form phi of u comma v is equal to 0, where u is a function of x, y, z is equal to some constant, and v is also a function of x, y, z which is equal to some constant. So an equation is of the form p into small p plus q into small q is equal to r, where small p is equal to dou z by dou x and small q is equal to dou z by dou y, is called a Lagrange's linear equation. And this equation can be solved by using the subsidiary equations dx by p is equal to dy by q is equal to dz by r, where p, q are functions of x, y, z. And this can be solved by using two methods, method of grouping or method of multipliers. And the final solution will be in the form phi of u comma v is equal to 0. That is the final solution formation, where u and v are functions of x comma y. So now see the problem. The first problem is solve the differential equation, partial differential equation p plus 3q is equal to 5z plus tan y minus 3x. And you can see that this is also in the form p plus q is equal to r notation. So this equation can be solved by using the Lagrange's linear equation. The second also the same form. The third equation also p plus q is equal to r. And the fourth one also, the equation is in the form x square into y minus z. It is capital P, small p, plus this is capital Q, small q is equal to r, where p, q, r are functions of x, y, z. So these equations can be solved by using the Lagrange's linear equation by considering the subsidiary equations. So now I'm coming to the first problem. So solve the differential equation p plus 3q is equal to 5z plus tan y minus 3x. So clearly this equation is in the form capital P small p capital Q small q is equal to r. That means what? This is an Lagrange's equation. So here capital P is equal to 1 and capital Q is equal to 3 and capital capital R is equal to 5z plus tan y minus 3x. So clearly P, Q, R are functions of x, y, z. Now the subsidiary equations, the subsidiary equations are dx by capital P is equal to dy by q is equal to dz by r. So how I can write dx by P means 1 and dy by q means 3 and dz by r means 5z plus tan y minus 3x, and call this is equation number 1. Now I am considering the first and second equalities and I will get a solution of the form u of xyz is equal to c. So I am taking first two. How you are solving this? I am taking first two. What you will get, dx by 1 is equal to dy by 3. Or what I can write, this is 3 dx is equal to dy, or plus c is the integrating constant. So on integrating, so I will write 3 dx. So on integrating, what you will get? On integrating both sides, on taking integration, what you will get, integral 3 dx plus c is equal to integral dy, or 3x plus c is equal to y, or what I can write, y minus 3x is equal to c. Y minus 3x. So I am writing 3x right hand side, you will get y minus 3x is equal to c. This is the first solution. This is in the form u of xyz is equal to constant. Similarly, you can use the first and last or something, and or second and third equations, and you will get the second solution. So how to I use this one is, I am using the first and third equations, first and third one. Now on taking one first and third. First and third means not this. This first and third, not equations. First and third in the inequality, you get equality dx by 1 is equal to dz by, what you can write here, 5z plus tan y minus 3x. Y minus 3x can be replaced by c. So dx by 1 is equal to dz by 5z plus y minus 3x is replaced by c. So the equation becomes dx by 1 is equal to dz by 5z plus tan c. Or what I can write here is dz by dx. So I am writing dx this side in the denominator. You will get 5z plus tan c. dz by dx is equal to 5z plus tan c. Or what I can write, dz by dx minus 5z is equal to tan c. Clearly, it is looking like a first order linear differential equation, ordinary differential equation, dy by dx plus py is equal to q model. Here dz by dx plus pz is equal to q. So this is a linear differential equation of first order in z. Here p means minus 5. P means this equation is in the form dz by dx plus pz is equal to q notation. Not p is dou z by dou x. P and q are functions of x only. Then p minus 5 and q is equal to tan c. Then the solution is z into e power integral p dx, that is minus integral 5 dx is equal to integral q. What is q? Q is a tan c into e power minus 5x. The solution is y into e power integral p dx is equal to integral q into e power integral p dx dx plus c. Or you can take as a constant k. Or what it is, z into e power minus 5x is equal to tan c is constant with respect to x this is, and this is integral e power minus 5x is e power minus 5x by minus 5, e power minus 5x by minus 5 plus k. Or what I can write is k is equal to z into e power minus 5x plus 5 into e power minus 5x into tan c is equal to k. So I am writing this term, first term on the left hand side will get minus, will get plus term, plus 5 into e power minus 5x into tan c. Or what I can write here is e power minus 5x I am taking outside, you will get z plus 5 into, what is tan C? C means what? What is our assumption from equation 2? It is y minus 3x is equal to some k, and call this is equation number 3. So clearly it is in the form function of x and z is equal to k, and this is equation number 2 is a function of y and x is equal to c. Therefore, the general solution is phi of, write the equation number 2, that is y minus 3x, and second one is z plus 5 into tan y minus 3x is equal to 0, which is the required solution of the given partial differential equation. So just to follow up the working principle. So if the given equation is in the form, linear form or Lagrange's linear equation, then we consider the subsidiary equations and solve the equations for getting the solutions, two types of solutions. On combining the two solutions, we'll get the required solution, which is the general solution of the given partial differential equation. So with this example, we can have some strong idea on Lagrange's linear equation. So I will do another problem also. Find the general solution of ZP plus YQ is equal to X. In a similar way, you can do that. So what is the equation? The given equation is partial differential equation is Z into P plus Y into Q is equal to X. So clearly it is in the form, in what form this is? Small p plus capital P, small q plus capital Q is equal to R, where P, Q are functions of x comma y comma z. So here what is P? Here capital P is equal to Z, because it is P into P notation. Capital Q is equal to Y, and capital R is equal to X. So these are the PQR values. Now, the subsidiary equations are dx by p is equal to dy by q is equal to dz by r. So what is p here? Dx by z, p is z, and dy by y, and dz by x. So take the equations and solve. Take first and last, you will get one solution. Take first and last. What is the first and last? This is called equation number 1. On taking first and last equations, what you will get? So dx by z is equal to dz by x. Or what you will get? X dx. X dx is equal to z dz. Or on integrating both sides, integral x dx is equal to integral z dz plus c. Or what is integration? X dx means x square by 2 is equal to z square by 2 plus c. Or x square minus z square is equal to 2c. Or I can write x square minus z square is equal to some constant c1, and this is the solution of the dx by z is equal to dz by x. Am I right? This is solution of dx by z is equal to dz by x. This is the first solution, and call this is equation number 2. But what you can write from the first equation, z square is equal to x square minus c1, or I can write this is equal to plus c. Suppose if I write like this, then what you will get? Z square by 2 minus x square by 2 is equal to c. Or I can write like this, that also. X dx is equal to z dz. Am I right? X square by 2. This is z square by 2. X square minus z square is equal to c. Or what is here? Z square. Z square is equal to x square plus c1. So I will tell you later. Now on considering the first and last equations, First and last equations you got this. Now on considering the first and x square z square, am I right? Square z square is equal to c1. All this is equation number c1. Question number 2. Now on taking dy by, now on taking first and second, dx by p is equal to, or dx by p means it is z is equal to dy by y. Now on considering first and second, on considering first and second, dx by z is equal to dy by y, or what I can write, dx by z square is equal to, what I can write, z square is equal to x square plus c. We can write like this, z square is equal to x square plus 2c. Can I write or not? X square plus 2c1. Z square is equal to, or z square minus x square is equal to c1. I can write z is equal to x square plus c1 under square root is equal to dy by y. Z square, x square, z square is equal to x square plus 2c means c1. Now on taking integration, integral dx by root of x square plus root c1 whole square. c1 I can write root c1 whole square is equal to integral dy by y plus some k, where k is the integrating constant. So what I can write on the left right hand side, that is integral dy means y by means log y plus k. It is a constant. And here it is 1 by root c1 into sine h inverse x by root c1. The integration. 1 by a square plus x square notation, sine h inverse x by root c1. Or what is the constant value? 1 by root c1 into sine h inverse x by root c minus log y is equal to some constant k, that is equation number 3. Here I am writing from equation 2, z as a function of x. So z square is x square plus c1, or z is equal to root of x square plus c1. It is 1 by root of x square plus root c1 whole square. So that means sine h inverse x by a formula. So on writing this formula, you get 1 by root c1 sine h inverse x by root c plus log y is equal to c, or k, log k or k, it is equation number 3. Now on writing equations 2 and 3, as I said, the general solution will be phi of the first constant c1 is z square minus x square, and the second solution k value 1 by root c1 sine h inverse x by root c1 minus log y is equal to 0 is the required solution of the given partial differential equation. So this is somewhat difficult in this model. Remaining all are very simple because it leads a lot of substitution and integration. This is also easy, but you need to substitute. You have to observe on integrating what function you will get on. Here it is a z term, it is a y term. There is no z term dz here, so that I am transforming z is in terms of x or y terms. So that is only the thing you have to observe. The remaining all are the same process. Finally, the solution is in the form of phi of the first constant value z square minus x square. The second constant value is k. K is 1 by root c1 sine h inverse x by root c1 minus log y, that is equal to 0 is the required solution of the given differential equation. So these are the problems based on Lagrange's linear equation. Now this also you can solve. So I will give clue and or I will solve it. So what is Lagrange's equation? This is P small p plus Q small q is equal to R. So here what is P? This is in the form of Lagrange's equation. What is P? Z square minus 2yz minus y square, and Q is equal to xy plus zx, and what is R? R is equal to xy minus zx. So the subsidiary equations are dx by p is equal to dy by q is equal to dz by r. That means what? Dx by P means Z square minus 2yz minus y square is equal to dy by xy plus zx is equal to dz by xy minus zx. xy minus zx. Now you observe the constants L, M, N. I'm multiplying L, M, N with dx, dy, dz respectively. These terms addition also should be the 0. In that way you have to find L, M, N values. Suppose if I add this, it will not be 0. Suppose if I add this one, this will not be 0. Suppose if I multiply with the x and y and constant, you may get 0. If I multiply this z square minus 2yz minus y square. Suppose if I multiply with x. And suppose if I multiply this with y, that is y into xy plus zx and plus some constant. This is z into some xy minus zx. Then you see the values. Here xz square. xz square 2xyz minus y square x plus y square x. These two gets cancelled. zxy plus zxy plus zxy. 2zxy. These two will be gets cancelled. And xz square minus z square x. Clear? I multiply the first numerator with x and the numerator with y and here the numerator with z. Then what will happen in the denominator? I am multiplying the same thing with x, y and z. What will happen? I am multiplying xz square. This is on expanding xz square. This is given as a homework to the students. That I will explain and you are supposed to solve. Xz square minus 2xyz minus xy square and plus this is y into xy, that is xy square plus zxy. Zxy, this is not 2zxy plus zxy and minus z square x. If you observe this, xz square gets cancelled. 2xyz, xyz will get cancelled. xy square cancel. That means what will come in the denominator? On adding all the three, we will get 0. That means what? X dx plus y dy plus z dz is equal to 0. On adding all these, multiplying x, y and z respectively and adding the denominator also, you get 0. So in such a way that you have to choose L, M, N. Here L is x and M is y and N is z. Now on integrating both sides, you get integral x dx plus integral y dy plus integral z dz is equal to 0 or some constant c. Then what is integral x dx means x square by 2 plus y square by 2 plus z square by 2 is equal to c. Or x square plus y square plus z square is equal to 2c. Or x square plus y square plus z square is equal to c1. This is the first solution of the given subsidiary equations on taking the coefficients L, M, N as x, y, z. I hope this is clear. X dx, y dy, z dz. On multiplying in the denominator successively with x and y and z, the denominator and adding all the terms will be 0. Then the equation will be, the denominator will be 0 and the numerator is 0. So the solution will be the first solution. Similarly, you find the second solution. You find L, M, N constants and by dividing x or something, you divide the equations, you find the values x, y, z or L, M, N and then the final solution will be the phi of u comma v is equal to 0 is the required solution. Already I have done one solution. Just you find the second solution and write the complete answer. That will be the challenge to you in this linear equations. So similarly, you do this problem also. So this also you can find easily. This also I will explain. You are supposed to solve one solution. This is also in the form PP plus QQ is equal to R. So what is P here? This is a linear equation, Lagrange's linear equation. No doubt. And what is P here? X square into y minus z. And what is Q? Y square into z minus x. And what is our z square into x minus y? So all PQ are the functions of x comma y comma z. Now the subsidiary equations dx by p is equal to dy by q is equal to dz by r. That is dx by p means x square into y minus z is equal to dy by q means y square into z minus x, and dz by r means z square into x minus y. Then what is each ratio is equal to? Each ratio is equal to, I can write each ratio. This is, I can write 1 by dx by x square plus dy by y square plus dz by z square by y minus z plus z minus x plus x minus y. All are you getting? This plus this plus this. Here dx by x square. I'm writing x square in the numerator. That way then it will come dx by x square. Y square in the numerator, dy by y square. Z square in the numerator, dz by z square. In the denominator you will get y minus z plus z minus x plus x minus y. Now on cancelling out, what you will get? The denominator will be 0. That means what? Dx by x square plus dy by y square plus dz by z square is equal to 0. Then what is the integration? On taking integration, integral dx by x square plus integral dy by y square plus integral dz by z square is equal to constant c. This is the integration is minus 1 by x power minus 2 dx integration. X power minus 2 plus 1 by minus 2 plus 1, or it is minus 1 by x integration. And similarly this is minus 1 by y integration, and minus 1 by z is the integration is equal to c. Or on taking out minus, you will get 1 by x plus 1 by y plus 1 by z is equal to minus c. Minus c can be assumed as another constant c1. So this is the first solution called, this is equation 2. This is 1 and this is equation 2. Each ratio is equal to dx by x square plus dy by y square plus dz by z square. So another ratio also you can assume that you need to find out. My idea is, or otherwise I will tell you each ratio. So in second part, how you have to take as each ratio, that is your option. You can do in any manner. But if suppose if you write the equation number 1 as, suppose in this way, I'll show it dx by x into y minus z is equal to dy by y into z minus x. Only I am writing 1x in the numerator as by x and 1y in the numerator in the second equation, and in the third equation dz by z into x minus y. Now each ratio is equal to what is dx by x plus dy by y plus dz by z by, on adding this one, xy minus xy, xy minus xy 0, xz minus xz 0, all are zeros, this is 0. That means what? Dx by x plus dy by y plus dz by z is equal to 0. So on integrating you will get log x plus log y plus log z is equal to some constant k, or you can assume it as log k. Then what is the log a plus log b plus log c? Log m plus log n plus log z. So I can write log xyz is equal to log k, or xyz is equal to some constant k. This is the second solution, that is equation number 3. Here also I am writing by writing x square in the numerator. Here also writing the ratio is equal to 1x on the numerator, remaining terms as in the denominator, so that there is no change. So that there is no change, and the equations will be, the denominator will be 0. The denominator will be 0, and on integrating you get the solution xyz is equal to constant. So the final solution, that is phi of u comma v is equal to 0 is the final solution, or phi of what is u? What is u? 1 by x plus 1 by y plus 1 by z comma, the second solution xyz is equal to 0, where phi is an arbitrary So in this way, we can solve the Lagrange's linear equations by considering the subsidiary equations and solving and writing the two solutions as one set. And here phi is an arbitrary. So this is the final part of the unit module number 3. So with these few problems, I conclude my today's lecture. And here the reference book is Dr. T.K.V. Iyengar, Dr. B. Krishnagandhi, S. Ranganathan, M.V.S. and Prasad. The book is a textbook of Engineering Mathematics by Volume 2 by S. Chan and Company Limited, year 2001. And the page numbers will be 175 to 180. You can observe that in this book. If you want to go for this book, the book will have in the library. And this book, we have the more problems and exercise also. So, you can verify this book. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.